Solve the following system of equations with the substitution method. If there is one solution, enter it as an ordered pair. So if we're solving this with substitution, the first thing we need to do is we need to isolate a variable on one side. So I'm looking, all of the variables have a coefficient or a number in front, except for this x. And so I'm going to go ahead and solve for this x. I'm just going to add the 3y to both sides. And so that will give us x equals, I'll make it 3y first, minus 14. So you can rearrange as long as you keep the signs in front of each term the same. So positive 3y minus 14. Okay, now I am going to substitute this in place of this x in the other equation. Okay, so I'm going to write out that equation, negative 6y equals negative 28 minus 2x. So this x is where I'm going to substitute that 3y minus 14. All right, let's go ahead and simplify. So we're going to have negative 2 multiplied by both. Don't forget about that negative in front because it will change both signs. So I still have negative 6y equals, now another thing I should have mentioned on this step, make sure you don't combine the negative 28 and 2 because we have to multiply first according to order of operations. Multiply comes before adding or subtracting, and so don't combine the negative 28 and negative 2. First we have to multiply that 2 in. So we get negative 2 times 3y or negative 6y, negative 2 times negative 14, which will become a positive 28. Now let's combine like terms on the same side. We can see I've got a negative 28 and a plus 28. Well, those are just going to cancel each other out. So those are completely gone. And now I have negative 6y equals negative 6y. So at this point you might see like, these, I just have two equations exactly the same. That's weird. So we could add 6y. We want to combine the y terms on one side. Well, what happens here? That's going to cancel and that's going to cancel, so I'm left with 0 equals 0. Well, when I have a true equation like this, a true statement, this tells me it's going to be infinite solutions. You also may have recognized it at this point, at negative 6y equals negative 6y, or here you might even be seeing like, something looks a little bit weird here. So anyway, you can keep simplifying though, and when you get to the point where it's simplified as far as it can go, you'll have to either decide is it infinite solutions, which this case would be because it's a true statement. If it's not a true statement, if it ended up something like 1 equals 7, which is not true, this is an example of one that would be no solution. Okay, so you solve this similarly to other problems, but you just have to know to stop when you get to a point where all the variable terms have canceled out and you're just left with constant terms.